Hi everyone, so now we're going to be talking about coordinate proofs, which basically means I'm going to give you a bunch of points and we're going to decide what those points make, what kind of shape it makes, or whether it makes a shape at all. Anyway, so we're going to specifically be talking about quadrilaterals. So let's go over 4 different types of quadrilaterals. The first one is a square, and a square has all the sides being the same length and all of the angles are 90 degrees. And so if I were to give you 4 points and say, is this a square? What we would have to figure out is if all of the sides, the distances between all of the sides are the same, and then also if the angles created a 90-degree angle. And the way that we would figure that out is by using the slope formula. And we'll do that in your examples. And then we have a rectangle, and a rectangle is like a square because you still have all the angles being 90 degrees, but now instead of having all the sides being the same, the opposite sides are the same. So the top and the bottom have the same distance or length, and then this left side and the right side have the same length. Then we have a rhombus, and a rhombus I like to kind of call like a smashed square because it still has all of the sides being the same length, but now instead of having all of the angles being 90 degrees, the 2 opposite angles are the same. So the top right, bottom left angle are the same, and then the top left, bottom right angle are the same. And then the last one is a parallelogram, and a parallelogram is kind of like a rhombus is a smashed square, a parallelogram is a smashed rectangle, and so the 2 opposite sides are still equal in length, but now the angles aren't all 90 degrees there. The opposite angles are equal. So for the first 2 examples, what we're going to be doing is taking 4 different points and determining what kind of quadrilateral they represent. So like we kind of talked about, we're going to need the distance formula to figure out what the lengths are, and then we also need the slope formula. So I'm going to write those down right here. So my distance formula is d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And then my slope formula, which we talked about in the last video, is m is equal to y2 minus y1 over x2 minus x1. Okay, so let's just start with this first example. And I'm sorry, all of this information right here is on your little key term sheet for this lesson too. So let's start with the first example. The first example, we have 4 points, -4, 2, -1, 3, 9, 3, and 6, 8. And we want to determine what kind of quadrilateral it represents. So the first thing I'm going to do is just kind of graph it to figure out what sides we need to find the lengths of. And you don't need to be too terribly specific, but because we're still going to use those formulas to figure it out, but we just want to make sure that we have them in the right order. So -4, 2 would maybe be right here. So I'm going to call that point A and then put an A right here just so I know which ones they are. The -1, -3 would be like right here. We're going to call that B. And then 9, 3 would be right here. We're going to call that C. And then 6, 8 would be right here. We're going to call that D. Okay, so now I can see that this is the quadrilateral I'm looking at. And from there, it kind of looks like a rectangle, but let's double check that. And the way that we're going to double check that is we're going to find the lengths of all of these sides to be able to compare them. So I'm going to start with side AB. And for side AB, once again, we're going to use the distance formula. So I'm going to have D is equal to the square root x2. So I'm going to use B as my second point. So x2 will be -1 minus x1, which is -4, squared, plus y2, which is -3, minus y1, which is 2, squared. All right, now I'm going to plug that into my calculator. So the 2 negatives in the first set of parentheses go to a positive. So I'm going to say -1 plus 4 squared. and then negative 3 minus 2 squared. And that's all under square root. And I get approximately 5.83. Okay, now let's go from, so A to B was kind of like our short side right here. Let's do the other short side. So C to D. Again, I'm going to make D my second point, so like x2, y2. So we're going to have x2, which is 6, minus x1, which is 9, squared, plus 8 minus 3. Those are my y's squared. Let's plug that in. So we're going to have the square root of 6 minus 9 squared plus 3 squared. And I get that that is also equal to 5.83. Okay, so those two sides are the same length. That's great. Now let's make sure that sides A to D are the same as B to C. So I'm going to do A to D first, which again, I'm going to use D as my y2, so I'm going to have, or my x2, y2, so I'm going to have 6 minus negative 4 squared plus 8 minus 2 squared. Let me plug that into my calculator. And I get 11.66. Okay, now let's try from B to C, because that's my other long length. I'm going to make C my x2, y2. So I'm going to have 9 minus negative 1 squared plus 3 minus negative 3 squared. And I would get same thing, so 11.66. So now I know that these are the same, but they're not necessarily, so it's either, it's either going to be a rectangle or a parallelogram, because we know the two opposite sides are equal to each other. So in order to decide if it's going to be a parallelogram or a rectangle, we just have to figure out if one of the angles is a 90-degree angle. Because here's the deal. If one of the angles is a 90-degree angle, then I'm going to tell you that all of the angles are 90 degrees. So I'm going to check this angle right here, angle A. And the way that I check that is, what I want to do is find the slope from A to D, and then find the slope from A to B, and make sure that those are negative reciprocals. If those are negative reciprocals, that means that they're perpendicular, which means they make a right angle. So I'm going to start with the slope of AB, which would be, again, the slope formula, y2 minus y1 over x2 minus x1. So I'm going to have negative 3 minus 2 on top over negative 1 minus negative 4 on bottom, which gives me negative 5 over 3. Okay, so my slope is negative 5 over 3. That's as simple as it'll go. Now let's go the slope from A to D. And I would have 8 minus 2 over, 6 minus negative 4, which would give me 6 over 10. When I simplify that, I end up with, because I can divide both top and bottom by 2, I would end up with 3 over 5. So here's my slope there. So I have a negative 5 over 3 and a 3 over 5. Those are negative reciprocals because they flip the fraction and change the sign, which means that that is a 90-degree angle. Because that one's a 90-degree angle, that means that all of them are 90-degree angles, which means that this has to be a rectangle. Hooray! So that does take quite a long time, but good news, we figured it out. So let's try the next one. So the next one, once again, let's kind of just start by graphing it a little bit, just generally, so we can kind of tell where to find the lengths of it. So negative 4, negative 3 would be about right there. We're going to call that A. 1, 2, we're going to call that B. 8, 1. We'll call that C. And then 3, negative 4. We'll call that D. All right, so now we can see once again that this is what we want. And that to me either looks like a parallelogram or a rhombus, because these don't look like 90-degree angles, but once again, we're gonna figure that out. So we're gonna do the same thing as what we just did on the first example. We're gonna find the distance between A and B first. All right, so when I do that, I'm gonna say 1 minus negative 4 squared plus 2 minus negative 3 squared. Let me plug that into a calculator. And I get about 7.07. Then let's do, so that was this length. Let's do the opposite length. So from C to D. So we're gonna have negative 4. Oh, I did Y, but so let me change that. Let's do it with X first. So we're gonna have 3 minus 8 and then negative 4 minus 1. Okay, plug that into a calculator and I get same thing, 7.07. So we know those two sides are the same. Let's check out what the distance between A and D and then B and C is. So let's start with A and D. So we'd have 3 minus negative 4, negative 4 minus negative 3. So let's see. Oh, we get 7.07. So it's the same as these other ones. Now let's just double check with BC. If it should be the same, but let's double check because you never know. So I'm going to start with 8 minus 1 squared plus 1 minus 2 squared. Okay, plug that in. And I get 7.07 again. Okay, beautiful. Which means all of these sides are the same. So because all of the sides are the same, that means that it's either got to be a square or a rhombus. Now we just have to double check one of the angles. And if one of the angles is a 90-degree angle, then it has to be a square. If it's not a 90-degree angle, then it's a rhombus. So once again, I'm going to check angle A. I don't think it's a 90-degree angle just based on the way that it looks, but let's double check. So I'm going to start with my slope between A and B, which would be y2. So 2 minus negative 3 over 1 minus negative 4. I'd get 5 over 5, which is equal to 1. So my slope from A to B is 1. Now let's do the other slope for angle A, which is from A to D. So you'd have negative 4 minus negative 3 over 3 minus negative 4, which gives me did I do that right? Negative 4, okay, yes I did. So I get negative 1 over 7. All right, so your slopes are 1 and negative 1 over 7. Those aren't negative reciprocals of each other. And so that means that this isn't a 90-degree angle. Because it's not a 90-degree angle, then the other ones can't be 90-degree angles, which means that it has to be a rhombus. Okay, so that's how we decide how what quadrilateral those 4 points represent. Now the next two examples talk about circles. And for the circles, we have to decide if points lie on the circle based on like where the center is and everything. So let's talk about circles for a second. Here I have a picture of a circle. And inside the circle, we have the center of a circle, which is right in the middle of obviously right in the middle of the circle. And from the center to the edge, to any edge of the circle is called the radius. So I drew it on the right side, but I could have drawn it on the left side or from at the top or at an angle or at the bottom. It doesn't really matter because the radius, no matter what, all the way around is the same length. So on these questions, it's going to give you a center and then a point that we know lies on the circle. And then we're going to ask, okay, does another point lie on the circle? To figure that out, what we need to do is find the distance of the radius or the length of the radius, and then see if the distance from the center to the new point matches it. So I rewrote the distance formula down here, but obviously we've already used it a couple of times. And once again, you don't have to memorize the distance formula. It'll always be given to you, but you'll probably end up using it so often that you'll want to memorize it. So let's go through this third example. It says, does the point 9, 1 lie on the circle centered at 6, 0 containing the point 3, 7? So we know the center is at 6, 0, and we know the circle already has the point 3, 7. So what I'm going to do is I'm going to find the radius of the circle. And to find the radius of the circle, we need to find the distance between these 2 points. All right, so let's start with that. So the distance, I'm going to just say 3, 7 is my second point. So I'm going to have x2, which is 3 minus x1, 6 squared, plus y2, 7 minus y1, 0 squared. All right, now let's plug that in. So we get the square root of, okay, and I end up with 7.62 approximately. And now because we know that's the circle and then that's the point or that's the center and then that's the point that lies on the circle. We know this is the radius for sure. So what we need to do now is figure out if this other point, this 9, 1, also makes a radius with the center. So I'm going to say now I'm going to find the distance between 6, 0, which is still my center, and 9, 1. So let's do that. So the distance, we're going to say 9 minus 6 squared plus 1 minus 0 squared. And we get, let's plug it into a calculator. Okay, I end up with 3.16 approximately. So these two numbers are not the same. So, which means that the point can't lie on the circle because it's not the same as the radius. So no circle. Or it does not lie on the circle is, I guess, the way that we would say it. All right. Let's look at this last one, which is the same as the third example. So it says, does the point -10, -76 lie on the circle centered at -3, 8, containing the point 4, 92? So we know that the center is at -3, 8. And then we know that a point on the circle for sure is 4, 92. So the first thing I'm going to do is find the radius by finding the distance between these two things. So I'm going to start with 4 minus -3 squared plus 92 minus 8 squared. Let's plug that into a calculator. And I get 84.29 approximately. So now we've got to figure out if the point -10, -76 it has the same radius with the center. So I'm going to find the distance between this guy and the center, which is -3, 8. Again, let's use the distance formula. So I'm going to have -3 minus -10 squared plus 8 minus -76 squared. Let's plug this into a calculator. And we get 84.29. Okay, so these two things are the same, which means that this point, this new point that we didn't know if was on the circle or not, creates the same radius or the same length between the center and the point, which means it has to be a radius, which means this is definitely on the circle. So yes, it is on the circle because it creates the same radius. So these things are a lot of work, but you're going to just end up using the same formula over and over again to determine what kind of quadrilateral coordinates make or if points lie on circles.